Lab Guy here. Oh, I see you've already met my newest project, Eleanor RGBY. Don't read that name incorrectly, it's Eleanor RGBY. And the proper name, her proper name is 104 Eleanor RGBY. The model number of this project is 104. So 104 Eleanor RGBY is the name of my color NBTV signal generator. I had a lively round of discussion after the last video I posted with a couple of fellows. At least one of them's in New Zealand. They both may be there. And they were asking me why I didn't just generate the NBTV signals directly from the Arduino. I can answer that quite easily. I have no clue how to do that. No idea. I do not want to get involved in any type of signal processing inside of a computer chip. I am a hardware man. I'm going to build my board as a frame buffer that holds 256 2 kilobyte frames as raw video frames. No sync, no digital sync formatting, nothing like that. The 4 outputs are red, green, and blue video, analog, no sync. The 4th output is Y, luminance and sync. That way, that output will directly derive a mechanical television of the NBTV standard with the proper analog input. Problem solved. The monochrome output will be derived by a resistor matrix from the red, green, and blue signals, and sync will be added to that video separately so that the frame buffer data format is as simple as it can be. It's 32 lines by 64 pixels per line. Scanning is from the lower right up and right to left in the NBTV standard. These frames are 2048 bytes perfectly. These correspond nicely to binary boundaries within the memory chip. The 512,244 bytes divides up perfectly into 256 of these frames. You can hand edit these in your favorite image processing software like Paint or Paint Shop. I use Paint Shop, Corel Paint Shop, or Photoshop if you are rich enough to afford that kind of software. So you could do it that way. What I do in Paint Shop is I bring in an image, I crop out an area that I want, like a face, and it's twice as high as it is wide. So no matter how big the image is, you cut a frame and you pull it out. I measure in pixels. I'm a pixel guy. So if I have it a clip that's 1,000 pixels high, it's going to be 500 pixels wide. I crop that, say it's a headshot, I crop that, and then I use the size function to rescale it to 32 by 64. And prior to scaling, you can perform functions on it like softening and sharpening, color adjustments, so that when you scale it, your undo button is your friend. When you scale it, the image can be quite recognizable if you do just the right amount of enhancements. And this is fun in and of itself. Just a quick insert here. I was starting to tell you about 20 years ago, I went on a kick of taking pictures of my friends and making them into desktop icons that were so recognizable they would blow your mind. A desktop icon, at least in Windows 95 back then, or whatever that or the next version was, is 32 by 32 pixels by 256 colors. So that was amazing. All right, so the mechanical TV pictures that we're talking about in NBTV are slightly better than that. They're actually two of those desktop icons stacked one above the other. So I learned how to do that in the book I'm about to tell you about. About 20 years ago, I went on a campaign after reading an excellent book called Beyond Photography, The Digital Darkroom. If you can find a copy, Richie is one of the authors from Bell Labs, the same guy as in Carnegie and Richie, the authors of C. The book is in the same format as the original C book. If you can find Beyond Photography, The Digital Darkroom, get a copy. Snatch it up. It is awesome. Even though it's out of date today, by today's reckoning, Photoshop and Paint Shop and Paint all originated in the pages of that book. So anyways, that's how I create my final size image as 64 pixels tall by 32 pixels wide, and then I save the image as raw data. Raw, the saved image. If we're talking monochrome, let's say, you save it to the disk. It is 2048 bytes. No headers, no formatting, nothing extra, just pixels. I will create a simple tool, software tool that will create the master file that goes in the ROM chips, 3 files, red, green, and blue, and it will it can be done on a command line. I might make a little menu-driven system as it gets fancier, where you tell it the destination name for the 3 files. They will end in .red, .green, .blue as the extensions. They will be 512,244 bytes in size, and they will have 256 cells inside. And the software you tell it the name of your source image as either a luminance only or 3 RGB frames in RAW, and it will copy those, and you tell it which frame number to put it in the memory. It's that simple, and it will create that as a file on your computer, and you copy that file to the memory card, stick it into the Eleanor, and then dial up the menu for load a new frame buffer, and you can save the existing frame buffer, so you never lose anything. That's my thought process on that. So let's take a closer look at the actual breadboard I've constructed right now. So here we are looking at the actual test fixture I've constructed for developing the software and for developing especially the code to program the memory chip right here. This is the 0.5 megabyte flash memory. So taking a tour of this, we of course have the Arduino, we have the LCD display, we have 4 I2C parallel ports, we have a flash card holder for the data file transfer card, and 2 encoders, rotary encoders with push buttons for control. So this is the state of the breadboard for software development at this point. The wood that you see was originally a side panel on a Motorola EVR film player from 1968. I've repurposed it as the base for our project, and of course I'm using 3 of these El Cheapo prototyping circuit board strips. I've pre-wired power onto those, and I've pre-installed some of the parts I plan to use. So this is the current state of the test board for Eleanor RGBY. So that's the breadboard and how I plan to solve the programming problems for each separate element, each control element, and the memory card, and the programming of the flash memory chips. I will create all of those functions prior to assembling my master board, which will have the RGB buffer, the state machine for driving it. It will be driven by a crystal, and the amount of computer interface required to get into it will be minimized, so that the control software on the Arduino will simply be the equivalent of a truck driver. It knows when to step on the clutch and shift the gears, and its primary big work will be the actual programming of the memory chips in place. The rest of the operation's pretty easy. It will control. You can select which frame from 0 to 255 that you want to display as a still frame, or you can set it up where you can tell it go from frame 10 to frame 100 and loop, and it'll do an animation on your mechanical TV up to, I believe, 20 seconds, 20.48 seconds of playback loop, which is perfect for demos of mechanical televisions. Hopefully the board won't be much larger than 4 by 5 inches. It will have a lot of small-scale logic chips, but that's the way I work. If I knew how to do gate arrays and had the $10,000 a year for a gate array programming license, I might consider undertaking that, and so on. So, anyways, that's where the project is currently at. I haven't done squat with the mechanical televisor in 2 weeks because of the new computer Salty, and thanks to the suggestions of Mr. Davey, I went and used the Anagram webpage, trying out names, which then inspired me, and I came up with the name. When I wrote down RGBY, which kind of sounds like Rigby, I decided to name the device Eleanor, and one of my favorite expressions is 10-4 Eleanor, and so the model is the 10-4 Eleanor RGBY. Don't say Rigby, it's the Eleanor RGBY NBTV signal generator, and that is the upcoming project. I will be working on the mechanical televisor, which I'm going to make an entirely analog machine. I watched Mr. Davies' videos, and I may have that name wrong, so don't hold me to it. I'm doing this from a very flaky, what's it called? That thing in your head where you keep memories. Oh yeah, memory. So, anyways, he built a televisor. Look it up on YouTube, the Arduino televisor, or Arduino mechanical television, and you'll find it. I want to know why all my searches for mechanical television all these years, his videos are 3 years old, all these years, never turned up his videos. What the hell? What the hell, YouTube? Their search algorithm sometimes just leaves me just astounded. Anyways, look that up. One other thing before I go. I promised a buddy of mine I'd give him a shout out because I appeared in an animated production recently, apparently. So if you get a chance, look on YouTube for Chris Hickory and watch his latest animated cartoon called Here's Karen. And you may or may not see someone who resembles this, using my real name, Richard. So, hi Chris, here's your plug. Let's get back to the show. Until next time, I'll say, Lab Guy out.